all of a sudden we realized that we may have to rewrite all the textbooks about the beginning of the universe.
You know, space is more crowded than you might think, and actually galaxies wind up interacting with each other. They actually will merge together.
What is really beyond the edge of the universe? The universe is filled with billions of stars, planets, galaxies, and plenty more that we have no idea is even there. But at the same time, everyone has been asking the same questions from the beginning of time. Where does the universe end? What is past the known limits? What is really beyond the universe? Even though there is no logical answer to any of these questions, we will shed light on some facts that will absolutely blow your mind. So, let's get started. The word universe means everything there is, meaning all things that can exist in all of space and time. And if it's everything there is, it means that the universe has no edge. Even if you assume that the universe has some limit, then everything that is outside of it has to be included in the universe. Scientists assume that the universe is either infinite or just very big, and it is very tough for them to decide which one of these two options is correct. In order to make a logical decision, astronomers look at the curvature of space-time on the scale of the entire universe. This way, they have been trying to depict the very shape of our universe, whether it is an infinite plane, sphere, or torus. To be truly infinite, the universe must be geometrically flat and therefore have zero curvature. And guess what? According to the current observations and measurements of the curvature, the universe is 99.6% flat. The remaining 0.4% might be the measurement errors. However, scientists are still not sure that these measurements are enough to conclude that the universe is infinite. And even in the case of a flat universe, space does not necessarily have to be infinitely large. Let me give you an example. If you look at the side surface of a cylinder, you will probably think it is geometrically flat because the parallel lines on its surface do not intersect. But here's the catch. The cylinder has a finite volume. The same can be true for the universe. It can visibly be flat, but at the same time closed in itself and have a limited volume. You see where I'm getting at? If not, then you need to understand everything about the universe that we can observe. Our universe came into existence roughly 13.75 billion years ago. And soon, primordial light started shooting across the cosmos and spreading throughout the early universe. At that instant, the universe itself was expanding. After the first initial burst, or the Big Bang, the inflation of the universe was slowed, but since then, the rate of expansion has been increasing steadily. According to scientists, this expansion is due to the influence of dark energy, and since its inception, the universe has been growing at an ever-increasing rate. Some cosmologists have estimated that the oldest photos that we can observe have traveled a distance of 47 billion light-years since the Big Bang, which means that our observable universe is approximately 93 billion light-years wide. Would you believe that? These 93 billion light-years contain all of the stars, planets, nebulae, black holes, quarks, quasars, and everything else that we can observe using telescopes. But one thing is for sure, the observable universe only contains the light that has had time to reach us. Now, I'm going to mess with you a little bit. I mentioned that the universe is 13.8 billion years old. So how can it be spread across 93 billion light-years? How come the light has had enough time to travel that far? Stunned, right? I bet you are. Well, let me get a fact straight. This facet of physics is the key to understanding what really lies beyond the edge of the observable universe, and whether we could ever get there. To explain this further, let us discuss the theory of special relativity, which states that objects that are close together cannot move faster than the speed of light with respect to one another. However, no such law holds true for objects that are extremely distant from one another when the space between them is, itself, expanding. In short, the objects are not traveling faster than the speed of light, but the space between the objects is expanding, causing them to fly away from each other at the speed of light. Some of you might question, is there a way to reach the edge of the observable universe? It's 2023, we should be able to do that, no? Theoretically speaking, we can, but only if we develop a method of transport that allows us to either, number one, travel faster than the speed of light, something which most physicists think is impossible, and, number two, transcend spacetime by using wormholes or warp drive, which most physicists also think is impossible. The theory of cosmic inflation suggests that the entire universe's size is at least 10 to 23 times larger than the size of the observable universe, which makes us think that we're missing a lot and really haven't seen anything till now. But the truth is, we can't see it or measure it. We don't even know what lies beyond the edge of the observable universe. So, wrapping everything in a nutshell, we don't know whether the universe is infinite, and even if it has an edge, we can never reach there to see what's really beyond the universe. However, scientists and researchers have presented several theories regarding what exists beyond the universe. And trust me, you're going to smash your head on the wall when you hear these theories. So, let me start with the first idea, which is pretty much easy to digest. And that's just because I want you to listen till the end of the video. Haha. Anyways, some astronomers think space outside of the observable universe might be an infinite expanse of what we see in the cosmos around us, distributed and spread across the same as it is in the observable universe. This somehow seems logical to me. After all, it doesn't make any sense that what's beyond the universe would be different than what we see around us, right? If you ask me, I can't envision a universe that has an end, like a huge brick wall lurking at its edge. I can wrap my head around the infinity of the universe. But you know what that means, right? Beyond the observable universe, you won't just find additional galaxies, stars, planets, and other forms of undiscovered material. You will eventually find every possible thing. And I mean it, every possible thing. That's not it. If we deep dive into this theory and follow it to its logical conclusion, then somewhere beyond the universe, there may be a planet similar to the Earth, and there may be another person who is identical to you in every possible way. Imagine it. There is another you beyond the universe, but slightly different, maybe an inch shorter in height with no hands. Or maybe the other you died 5 years ago in a car crash. The fun fact is that this other you might also be listening to this video from beyond the universe, given the planet is that technologically advanced. The only difference is that the other you just picked their nose while you didn't. Or did you? Sus. To be honest, this idea is inconceivable, but yet again, infinity is inconceivable as well. Another theory refers to something called dark flow, which goes back to 2008 when astronomers discovered something very strange. Galactic clusters were all streaming in the same direction at approximately 2 million miles per hour. At first, it was very difficult to explain, but later, astrologists came up with an explanation stating that massive structures outside the observable universe were exerting gravitational influence. As far as these structures are concerned, they could be anything, a combination of matter and energy on scales we cannot imagine. They might even be huge warps in space-time that are guiding gravitational forces from other universes. Although we cannot depict what these massive objects are. Some recent analyses have claimed to debunk the dark flow model. However, this debunking is still disputed. Have you had enough, or would you like me to continue with more theories? Okay. Just one last theory, and then we'll wrap up this topic. This theory involves a universe of universes. Now, let me explain. Some scientists believe that our universe could exist in a small bubble amid a vast array of other bubbles. They call it a multiverse. And as strange as it sounds, the idea suggests that these universes can come into contact with one another due to gravitational forces between them. And when they connect, a big bang like the one that created our universe may occur. So that's it. These were just a few of the more popular theories. What are your thoughts? Do you think the universe is infinite? If yes, then what do you think is beyond the universe? Tell us your thoughts in the comment section. We'll see you in another video. Until then, take care.